Shop equipment frequently have two push-button toggle switches to turn things on and off. I recently worked on a project where I wanted to replicate this behavior to control an appliance and do it inexpensively. My hope was to get by with junk bin parts. Looking around at my spare parts, I found a project box, a couple momentary switches, and a relay with contacts rated above what I wanted to control. So I started with these items. It was a double pole relay. My thought was to use one pole of the relay to hold itself energized, and the other pole to switch my device. So one switch energizes the relay, and the relay then holds itself closed. This should allow me to turn on the device. I figured a transistor could be placed between supply voltage and the relay's coil, with the base wired to the supply voltage. The off switch could then be connected to the base of the transistor and ground. In this configuration, the transistor would normally be on, allowing the relay to be energized. But when the button is pressed, the transistor would turn off the power to the coil, switching the relay off. I wired it all together, and it worked! The relay circuit was too big, though, to fit in the project box. So I wired the switches through a 4-conductor wire and put the circuit in a separate box, next to the switched item. Even though it worked, I wasn't too wild about having high voltage and low voltage running through the different poles of the relay. It seemed like a pretty bad hack. While I worked on other aspects of the project, I ran across something called a power tail. This looks like a short extension cord, but it has a twist. It has a solid-state relay built into it. Normally the outlets are off, but place a low voltage across these connectors, and the outlets will turn on. This seemed like a much better solution than my relay hack, so I completely rethought my approach. I could have simply replaced the high voltage side of the relay circuit with a low voltage source going to the power tail's connectors. This would have worked, but now the relay seemed way overkill. I had a low voltage circuit controlling another low voltage circuit through the relay. Instead, I replaced the relay-based circuit with a flip-flop circuit. These can be built from discrete components, but I had a quad NAND gate chip in the parts box, and this would shrink the size significantly. I wired up the new circuit, and it worked, a much cleaner approach. As I worked on other aspects of the project, I had a realization that flip-flop circuit was small enough it could fit in the project box along with the switches. If I reconfigured the 4-conductor wire to have voltage, ground, and signal, I could move the circuit to the box. In the end, I did this, as it allows future changes to the switching mechanism. Right now, I have the 2 push-button toggle switch configuration, but at some point I'm thinking I want to have a current detecting switch to turn one appliance on and off, based on another appliance being on or off. This is easily done with the new configuration, but it wasn't so convenient with the old. So that's my story about how this design evolved over time as I discovered new resources and thought about the problem at a deeper level. Catch you next time.